We have spent 7 generations of dumping carbon dioxide into the world's largest junkyard, that is our atmosphere. And now we have about 1 generation time to clean it up. Any volunteers? Welcome to follow my lecture series, and today we will talk about climate change. We will have an overview of what it is about and what its impacts are. Let's start with a definition of climate change. This definition comes from NASA, from the United States. This is a long one, but I think that this definition does not have any extra words in it. So let's try to concentrate on every word. Climate change is a long-term change in the average weather patterns that have come to define Earth's local, regional and global climates. These changes have a broad range of observed effects that are synonymous with the term. Changes observed in Earth's climate since the mid-20th century are driven by human activities, particularly fossil fuel burning, which increases heat-trapping greenhouse gas levels in Earth's atmosphere, raising Earth's average surface temperature. Natural processes, which have been overwhelmed by human activities, can also contribute to climate change, including internal variability, for example cyclical ocean patterns like El Niño, La Niña and the Pacific Decadal Oscillation, and external forcing, for example volcanic activity, changes in the Sun's energy output, variations in Earth's orbit. So, the planet is warming and it is not explained by any natural things nor any external things such as volcanoes or changes in the Sun's activity. It is explained mostly by our own activity, the human activity. Of course, NASA here refers to observations. So let's see what kind of impacts we have had. This one. WMO said that 2023 smashes global temperature record. And you can see the stripes. They are from Show Your Stripes campaign. Each stripe, each vertical stripe is a year. And if that year was cooler than average, then that stripe is blue. And if that year was hotter than average, that stripe is red. If you look at those stripes, then you can really see that yes, the global average surface temperatures have risen a great deal, and the increase has been quite fast during the last decades. So, the planet is warming. What does it mean? It's warming, it's numbers, but does it have any real impact? Well, for example, this one. This is from summer 2023. Maui fires. Death toll hits 80 as officials say rebuild efforts could top 6 billion. Okay, but that was during the fires. The actual death toll was higher and the cost, of course, was also higher. And this happened in Maui, that is in Hawaii, that is in the United States. We often have the tendency of thinking that something bad happens in the global south, not where we are, but it actually happens in the Western world as well. But okay, this is the United States, it's on the other side of the globe, so maybe we don't need to worry about it. Let's see. This one is a scientific paper from one of Nature's papers, which means that from a very high-profile paper. Heat-related mortality in Europe during the summer of 2022. Doesn't sound very dangerous, does it? Not until you read the paper, which says that yes, probably about 60,000 people died prematurely because of the heat wave in 2023. If we had 300 planes crashing around Europe, I think we would have had rather sizable headlines, wouldn't we? But when we talk about climate, well, it was a bit hard and some elderly people died. Yes, but not only elderly. A lot of people died. And if you have been following the news, 2023 was actually hotter than 2022. So probably the death toll in 2023 was higher than in 2022. And let's get further. The death toll in 2024. I'm recording this in July 24, so I don't know. But if someone has been following the news lately, then it's been full of headlines of it being extremely hot close to the southern European countries. So this is actually in Europe also. And interestingly, Europe is not prepared for rapidly growing climate risks. And this paper says that we are not prepared and we are at risk. And interestingly, it also says that Europe is the fastest warming continent in the world. Whoops, it didn't happen elsewhere, did it? This paper is not a paper by some group of environmentalists. This paper is by the EU Commission in 2024. But let's have some numbers and graphs, because they are of course more convincing than adjectives. At least they should be, because numbers speak louder than words. At least they should speak louder when we talk about environmental things. So if you look at these curves, if you look at the curve on the left, it gives the global average surface temperature, which is averaged out, so it has a rolling mean of 5 years. And you can see that yes, it has been warming a lot. There are a little bit of ups and downs, but the trend is very, very clear for the last decades. On the right-hand side, you can have the year-to-year data from a little bit different data sources. And if you look at the year 2023, then you can notice that yes, it actually reached the plus 1.5 centigrade limit, which the politicians are talking about because it is in the Paris Agreement. Doesn't look very good, does it? A little glimpse of hope, of course, is that there is a lot of inter-year variation, which means that next year or the year after might be cooler, or then not. Samantha Burgess, Deputy Director of the Copernicus Climate Change Service, said about this data that 2023 was an exceptional year with climate records tumbling like dominoes. Okay, what does it mean? Is it that we just sort of hit the record high in our records, that is in the measurement history, like for 150 or 200 years? That doesn't sound too bad, does it? No. Not only is 2023 the warmest year on record, it is also the first year with all days over 1 centigrade warmer than the pre-industrial period. Temperatures during 2023 likely exceed those of any period in at least the last 100,000 years. Oh boy, we are great! We smashed a record which has been there for 100,000 years. Well, let's look at that record, because here we have the paleoclimatic curve. This is the estimated global average surface temperature for the last 500 million years. We don't need to worry about the left-hand side because it has that very old data. Please note that the x-axis scale is constantly changing, so be careful with that. Let's start from the right, that is from today. We see that for the last 10,000 years the global average surface temperature has been pretty even, which is to be expected because the ice age sort of ended 10,000 years ago. And before that it was a bit cooler. And then we can see that yes, in the Eemian period, at the end of the Eemian period or close to the end of the Eemian period, we had a peak at about 100,000 years ago. And that is what Samantha Burgess was referring to. So that peak, 100,000 years ago, was warmer than what we have today. Now, interestingly, as our globe is warming up, when we have El Niño, which heats the planet periodically, maybe every 7 years, next time or the next time or the next time, maybe 30 years from now, then the temperature will surpass that peak. And now if you look at that graph, when we get above that peak 100,000 years ago, when was last time as hot as it will be around 2050? 5 frigging million years ago. Go figure, 5 million years ago. We have been able to accomplish all this within 7 generations of polluting our atmosphere. So we're talking about really huge things. We're not talking about whether it's exceptionally hot or wet, winter or summer or whatever. We're talking about global surface temperature averages. And one more. This is the monthly data for last about 80 years. Every curve there represents 1 year. And if you look at the colors, the old years are sort of blue like 1940s, 1950s, and then it becomes redder and redder, so they are encoded by those colors. So the colors don't represent temperatures, they represent years, age of data. And if you look at that top curve, you can see that the last 12-month period as of recording this video has been by far the hottest in record. And really by far, it's exceeded 1.5 centigrades every single month. So now the Paris Agreement 1.5 centigrades doesn't sound very feasible, does it? It doesn't mean that we wouldn't need to struggle and we wouldn't need to do everything we can to stop the development. But now you can see the magnitude of the problem and the speed of progress. What causes it? Well, yet another curve. The cumulative CO2 emissions to the atmosphere from the dawn of the industrial era, that is around 1750 to 2022. So that's the dark area. So it seems that we have been able to push a lot of carbon dioxide, and now what is a lot? If you look at the scale, it's gigatons. Gigaton is 1 billion tons or 1,000 million tons. By the way, during this lecture course I'm using the American way of saying billion when I mean 10 to 9, so 9 zeros, and trillion when I mean 12 zeros. Be careful with those, it's easy to slip sort of 3 digits. But anyway, we talk about gigatons and we talk about thousands of gigatons. That's a lot. So we have been quite productive. And now that orange line there represents the limit at which we go permanently above 1.5 centigrades. So with today's emission rate, which is depicted by the hatched area, we will surpass that limit in 2028, and there is nothing we can do to keep under that limit, because we can't stop all our emissions today or next year. And because actually the emission rate is increasing, not decreasing, so we are accelerating, it means that most probably we are going to smash the limit in 2027, 2028, a couple of years from now. This is the problem. We have to very rapidly stop the emissions, or at least scale them down by 90%. Most probably we will have to swoop up some carbon dioxide from the atmosphere later on. There are technologies, but it's going to be difficult. At this point I would like to say a few words about data sources. For carbon data, there are a couple of places where you can find very good, very granular, very high quality data. One of them is the Global Carbon Project and its sister site, which is Global Carbon Budget. And they are exactly what they say. You have a lot of information on emissions, you have information on how much we can emit before we reach 1.5 centigrades or 2 centigrades and so on. And then for the observations, Copernicus Climate Change Service C3S, they use a lot of satellite data and they are associated with the European Union, but also they have a lot of cooperation with, for example, ECMWF, European Center for Medium Weather Forecasting, and so on. So these are scientifically sound sources for getting climate data or emissions data. So why is this so difficult? One of the things is the timescale. Nothing happens today, nothing happens next week, nothing happens next year. Our human biology is geared towards Where do we get our next meal? Whom do we mate with next? And that sort of things. We are not very good at planning decades or centuries before, and that's one problem. Nothing happens in a year, things happen in decades, a lot happens in a decade, but then we have some very slow processes like melting of glaciers, which even if we stopped all emissions today, would go on for maybe 1,000 years before reaching some sort of equilibrium, an end state. So that's one thing. The timescale is difficult. Timescale is difficult also from the political perspective because the timescale of politicians is usually about 4 years for natural reasons. The timescale for companies may be a quarter or 3 months, or it might be a couple of years, but seldom much longer. So this is a problem, the timescale. Then another huge problem is that this is a tragedy of the commons in the largest possible scale. Tragedy of the commons is an economic term coming back from the 19th century Britain, where people had their cattle on a common field. A village had a common field, and everything went well when you had, say, 10 cows on that field. You got a lot of milk and everything was fine. Then someone got rich and bought another cow. You had 11 cows. Well, that's a bit of a problem because then the cows grazing there didn't have enough grass. They didn't give that much milk. Then someone else got rich and got another cow and you had 12 cows. And it was a rational move for the new cow owners, but actually destroyed everything because then no one got milk. And this is a similar thing. We all should cut our emissions so that we all would benefit. But if I cut my emissions and the others don't, that one doesn't, then no one gets any benefits. Why would I jump under the bus because someone else would get a benefit? So it's a tragedy of the commons, and we know that market economy is not going to fix the tragedy of the commons. It needs some guidance, for example, pricing of externalities, that is carbon pricing, but we will talk much more about that later on. Then one problem, a biological or ecological problem, is that climate change will lead to mass extinction. It will lead to huge biodiversity loss. And we can't do anything about it. But we can sort of adjust how huge. So we have to do a lot. But then caring about biodiversity is important, but if we fail to get these climate change things sorted out, then biodiversity will go out of the window in any case. And then finally, battling climate change requires transitions that are very, very, very extremely expensive. How expensive? Well, this is one estimate. We would need to invest an amount of money that is globally ranging from $100 trillion to $300 trillion before year 2050. So that is actually, 1 0 0 and then 12 other zeros. So 1 and 14 zeros, or 3 and 14 zeros. A couple of $100 million. And if you divide that by 25 years, which we about have here, then we talk about 10 trillion, $10 million a year. That's a huge amount of money. It's about maybe $1,000 per person in the world per year. And this estimate does not, again, come from any group of environmentally concerned economists. This comes from the very well-known environmental agency called Barclays Investment Bank. And if you know any investment bankers, you know that they don't usually go with the flow when it comes to soft values. But if you look at the link, you see that it says that green transition driving force behind a radical economic rethink. So even investment bankers who have to think decades, they realize that yes, we'll have to rethink a lot. But okay, I want to end with sort of an optimistic notion. And of course that optimistic notion is that if we have something that we as the humankind need to invest $10 trillion a year, then there will be a lot of business opportunities. And let's see how we can seize them. See you next time.